Hi everyone, in this video we're going to be looking at how we can work with significant figures and scientific notation. So we'll start off with significant figures, or sig figs, and they are counted from left to right, starting at the first non-zero digit. Non-zero meaning a digit that isn't zero. So for example, looking at these numbers, if we're trying to count how many significant figures there are in this first number that we see here, so 0.00217, so we want to start at the first non-zero digit. So we're going to start here and then keep going until we get to the last non-zero digit, or in this case, the end of the number. So here we see that there are 3 sig figs. Right, the zeros in front of it, we consider them as non-significant. That doesn't mean we can just get rid of them because they still hold a place value, but in terms of this, they're not significant. Looking at this next one, starting with the first non-zero digit, which is 3, and we don't just finish at where we hit the first 0, we keep going until we get to the last non-zero. So in this case, all the numbers are significant. We will say that here there are 5 sig figs. The decimal point doesn't count as a significant figure, by the way. Lastly, looking at this one, so the first non-zero is 2, and we go to the last non-zero, which is 3. So in this case, we have 4 sig figs. That doesn't mean that we just get rid of the zeros again, because this number is saying 2,403,000. We can't just chop off the zeros because that would be just 2,403, which is much different to 2,403,000. As for significant scientific notation, so in scientific notation, or standard form as it's sometimes known as, very large or very small numbers are written in this particular form, and we'll go into this. So the main thing, first of all, is this times 10 to the power of something. Every number that you write in scientific notation will be times 10 to the power of something. What we need to do is have a number sitting in front of it. So I've just called this A, and this A needs to be between 1 and 10. So basically it needs to start off with a number that's not 0. So it could be like 1.23, for example. So it would be like some decimal place with one number, like say 2.39. Basically, that the number before the decimal point needs to be just one single number. Then we have the times 10, which, as I said, times 10 is always the same. And then the to the power, that power is representing how many times we move the decimal place. So how many places the decimal point moved. And the direction in which the decimal point moved determines whether that power is going to be positive or negative. We'll have a look at that once we get to the examples on that. So for a few example questions, first of all, we need to see how many sig figs there are in these numbers. Well, starting from this first number, the first non-zero is 6, and we go to the last, so there are 3 sig figs, because those are all significant. So looking at this second one, our first non-zero number is the 5, and we go to the 8. So in this case, there are 2 sig figs. And then this last one, the first non-zero is 4, and we go to the last non-zero, which is 1. All the other numbers are zeros, so they're still important, but we don't call them significant. So there are 3 sig figs here. Going into example number 2. So what we could also do is we can round numbers to significant figures, or to however many significant figures. Kind of like what we do with decimal points, but rounding to decimals is fine, but you might have a number that is very large and doesn't have decimal points at all, or conversely very small. And so if you have like 0.00000053, for example, rounding it to 2 decimal places won't be very useful. So what we do here is sig figs are always based on finding the first non-zero number. So in this case, the first non-zero is a 5, and we want to do 2 sig figs. So we're going to go across 2 places afterwards until we get to there. So we've gone across 2. The number after 7 is a 2, and the normal rules of rounding apply here. So if that number was 5, 6, 7, 8, or 9, we would round up. However, if it's 0, 1, 2, 3, or 4, we'd round down. So with this rounded to 2 significant figures, there's a 2, so we're going to round down. So it's just simply going to be 57. We're going to write that 57 and then replace everything else with 0. So what we're saying here is this number, 57,263, is about equal to 57,000. All right, so it's rounding, it's making estimates. Starting with this second one, again, we're going to find our first non-zero number, starting with a 3, and we're going to go across 2. So the number after that second digit is a 6. Because that number is greater than 5, that means we're going to round up this time. And so we're not just going to get rid of these zeros, we've got to keep those zeros there. So it's going to be 0.0037 because that 6 has been rounded up. In this case, because it's after the decimal point, we can actually chop off the 6, 1, and 2. We don't need to replace them with zeros. We can numerically be the exact same, but when it's after the decimal point, you can chop off any numbers afterwards. Lastly, if we're looking at this one, the first number 0 is 2. We go across and ending there. So the number after the 4 is the 8. And the 8 tells us that we're going to round up. So we're just going to say it's 25. We don't need to write 0.0000. Again, mathematically and numerically, that is fine. But because it's after the decimal point, we can chop off any numbers that are not significant. So we're saying 24.8706 is approximately 25, which it is. It's pretty close to it. Lastly, if we want to write numbers in scientific notation, and I say here correct to 3 significant figures, what we're going to do first is we need to move our decimal point so it's after the first non-zero number. Now, in this first example, there is actually no decimal point. So what we do, if there is no decimal point, we just put 1 at the end. And what I need to do now is move this decimal point so that it's after the first non-zero number. So what we're going to do, we're going to move this across. So 1, 2, 3, 4, 5. So I'm going to be moving my decimal point 5 places to the left. So when I write this in scientific notation, I'm going to write 2.42. Now I'm only going to stop there because going back to, I also want to do 3 significant figures. So going across here, the number after 2 is a 3. So it is it's going to round down. So we have 2.42. And you're going to write times 10 to the power of 5. Why is it 5? Well, like we saw, we moved that decimal point 5 places to the left. So it's to the power of 5. Looking at this next one, we already have a decimal point, so we don't need to add anything. So we're going to go 1, 2, 3, 4. Remember, we want to put it after our first non-zero number. So we're going to have something there, but then also looking at this, we want to round this to 3 significant figures. The number after 2 is a 7, so that tells us we're going to round up. So we're going to have 3.43, because we rounded up that 2, times 10 to the power of, and here we remember we saw that we went 1, 2, 3, 4, but we went 4 to the right. So because I went to the right, I'm going to say it's negative 4. And that's an important thing when it comes to scientific notation. If it's went to the left, it's positive. That power is positive. However, if you're moving the decimal place to the right, that means you're going to have a negative power. It's really important that you do that. Looking at these last 2 examples. So again, we don't have any decimal points, so let's just move this. Let's just create one and move it so it's after the 3. So 1, 2, 3, 4, 5, 6, 7. And then also we want to round this to 3 significant figures. So going across here, the number after the 4 is a 7, telling us that we're going to round up that 4. So we're going to have 3.25 times 10 to the power of, and I can't remember, so 1, 2, 3, 4, 5, 6, 7. So I've moved that decimal point 7 places to the left. And as we said, we moved the decimal point to the left, so it's going to be positive, so 10 to the power of 7. Then lastly, here's our decimal point. We're going to move it so it's after the 1. So 1, 2, 3, moving it 3 places to the right, and also rounding to 3 significant figures. So 1, 2, 3. The number after 3 is a 1, so we're going to round down. We're not going to change anything. So our answer is 1.03 times 10 to the power, and we moved it 1, 2, 3 to the right. Because we moved it to the right, it is a negative power. So there we go. That's how we can count significant figures, round things to significant figures, and also write numbers in scientific notation according to some amount of significant figures. Hopefully this helps.